Today's lesson we'll be talking about graphing trigonometric functions in section 5.3. So here we'll start with the general ones of sine and cosine. So graphing sine and cosine, we'll use the basic values. And notice that on the unit circle there's only a few nice numbers that happen for sine and cosine, where you have them at the ends of the x-axis and the top and bottom of the y-axis, where you get 1, 0, 0, comma 1, negative 1, comma 0, and 0, comma negative 1. Okay? Everything else has some type of radical in it, except for like when you have 1/2, but that's not very consistent. So we want to try to be able to have values that that we graph using these ones. Okay, that makes it easier for us to graph, so therefore we're not needing a calculator to graph it every time. Now there will be some problems where you'll need a calculator because you'll get decimals and your stuff will shift and move, go up and down. So certainly we'll need a graphing calculator, especially when we get to topics like harmonic motion. But to begin with, we want to learn using easy values so we kind of understand how to construct trigonometric functions or graphs, because they are pretty complicated. So starting with sine, and this is just the parent function, so we always try to graph 5 values for sine and cosine. We use 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, doing this divides our graph up into 4 sections. Okay, so we're looking at 4 areas, just like we would divide it up into 4 quadrants. Same way. So if I'm plugging in 0 into sine, when I plug this in, I plug it in and look at my unit circle, and then I judge what those values are to graph. So here, plugging in 0 for sine, looking at my unit circle, the y value for sine at 0 is 0. So then that's what I plot. So 0, 0. And then for pi over 2, we go to there, my sine value is 1. So then sine of pi over 2, where 90 degrees is 1. Sine of pi will be 0 again. Let me graph that. Forgot to graph that first one. Okay, and then 3 pi over 2 is going to be negative 1. Okay, and then going back to 2 pi, which is the same thing as 0, is 0. So here I have the graph of sine of x, gives me that picture. Now, that's what sine will usually look like. It'll be a oscillating graph that goes up and down. And one other thing you need to know is that this is a period, or one cycle of sine. What a period means is that you're going from start to start before it repeats. Okay, because if I plugged in 5 pi over 2, that would be the same thing as pi over 2, which would get me back to 1, so I'd start the process over. So you usually go up and then back down and then back to the middle for the start to start. So here, let's look at what cosine would look like. So same values, 0, pi over 2, and 3 pi over 2 and 2 pi. So 0. Okay, so plugging in 0 for cosine, 0 at cosine, or 0 for cosine would be 1. and then cosine at pi over 2 is 0. Cosine at pi is negative 1. Cosine at 3 pi over 2 is 0 again. And then cosine at 2 pi is 1 again. Okay, so notice how we got back to the value of 1. So graphing this, we have 0, 1, we have pi over 2, 0, we have negative, or pi, negative 1, and then 3 pi over 2, 0, and then 2 pi, 1. Okay, so then the graph for cosine looks like that. Okay, now if you notice between the two pictures, if I shifted cosine over a value of pi over 2 to the right, it would be the same thing as sine of x. Okay, and then doing the same thing for a sine, if I shifted that value to the left, that equals cosine of x. Okay, so these are kind of complements, if you will, of each other. That's why, like, when we're doing stuff with the triangles, if I have sine of some value or one angle, then the other angle's cosine will be the same value. That's why that relationship works really well. So here, let's go ahead and start graphing. Okay, now here how I'll graph is we'll always use those values, okay? Because we're always starting with the parent function, okay? So okay, so 0 is always 0, pi over 2 is 1, pi is 0, 3 pi over 2 is negative 1, and then 2 pi is 0 again. Okay, but now if we take those values and add 2 to our function, so let's go back and erase this and say what? It's sine of x. So now sine of x plus 2 means that when I take the trig function, then I actually add 2 to all those values, making it move upward or moving it downward because I'm adding or subtracting to the outside of my trig function. So 0 plus 2 is 2, 1 plus 2 is 3, 0 plus 2 is 2, negative 1 plus 2 is 1, and 0 plus 2 is 2. So when I graph this, so let's say now we shift everything up, so then 0 is 2, pi over 2 is 3, pi is 2, 3 pi over 2 is 1, and 2 pi is 2. So then I get the graph. So it looks exactly the same as what we started with, but now we shifted everything up a value of 2. Okay. Vertical stretch, when I graph and I'm multiplying the cosine or trig function by a value on the outside, that makes it makes the amplitude go up. Let's go back to that first picture. So amplitude is the distance from the top to the middle, or to the bottom, or to the middle to the bottom. Okay, so amp for these ones, for the parent functions, are 1 always. But then when we start multiplying by other values, like let's say 2, then we take whatever our trig value is for that and we multiply it by 2, or whatever that value may be. So So here, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so here, if I find my values for cosine, so the values would be 1, 0, -1, 0, and 1 again. So now here, if I multiply by cosine of x, that means 1 times 2 gets me 2, 0 times 2 is 0, -2 times 2 is -2, 0 times 2 is 0, and 1 times 2 is 2. So we get the same values, except we're just amplifying them by value 2. Okay, so when I graph 0, 2, pi over 2, 0, pi, -2, 3 pi over 2, 0, and 2 pi, 2. So then my graph just gets stretched out by a value of 2. Okay? Now the last thing for this part 1, we'll talk about horizontal translation. So here, doing the same thing, except now we're moving it from left to right. So now what we need to do is we need to actually take our value, or our values that we have for x normally, and we need to add pi over 2 to each of them. Sorry about that, not add pi over 2. Now this one's tricky, and that's why I forgot. We need to do the opposite, because inside, since we're talking about left or right, we always want to do the opposite value of that. So adding inside, kind of like if we're talking about a parabola, inside the parentheses always does the opposite of what we want it to do. So this is actually saying left pi over 2. If it was a subtraction sign, we'd say right pi over 2. That's where I got confused. So instead of adding, I will subtract to negate that movement, because we always want to kind of get back to our 0, pi over 2 pi, 3 pi over 2, 2 pi. So doing the opposite gets us negative pi over 2, 0, pi over 2, pi, and 3 pi over 2 initially. So now when I plug them in, I get sine of negative pi plus pi over 2, which is sine of 0. That gives me 0 for that value. When I plug in pi over, or 0, 0 plus pi over 2 gets me back to pi over 2. So then that gives me my 1. And then sine of pi plus pi over 2 is 3 pi over 2. Oops. Sorry, I'm looking at the wrong one. So sine of pi over 2 plus pi over 2 gets me sine of pi. That gets me 0. Then sine of pi plus pi over 2 is sine of pi, 3 pi over 2. Gets me negative 1. And then sine of 3 pi over 2 plus pi over 2 gets me 2 pi. So that gets me 0 again. Okay. Now, these are my new x values that I graph. So on my graph, it'll look a little different than what I had before. So here I'll start with 0. And then I go up 1, and then pi over 2, and then pi, and 3 pi over 2. The reason why those are my new x values is because that's what I plugged in to my function here. I plugged them in here because 0, or negative pi, plus pi over 2 got me 0. Oh, whoops. Got me the 0 that I got there, which happens to be the same as that. Okay? but I plugged in negative pi over 2, so that should be the new x value that I'm graphing for my function. Okay? Have fun. See you in part 2.